being whether the wheel profile is perfect or not. If the wheel profile is not proper, then the vehicle is supposed to be taken for turning. So the wheels would be turned so as to ensure that it always passes, the profile always passes through this wheel defect gauge. Now, if assuming a passenger train accident has occurred, a large amount of equipment goes for restoration work. So, a passenger train going from Baroda to Ahmedabad is met with an accident at, say, Anand. As soon as the accident happens at Anand and it's a passenger train accident, the disaster management plan of the Indian Railways will cut in. So, assuming Anand is in Baroda division, and Baroda division will start alerting its accident relief trains, and they'll say that you have to go to the site immediately. Now, the site, when the people reach on the site, the first priority always is to rescue. You have to provide succor to the people who are there inside the train. You have to start rescuing them, and you use a large amount of equipment for this purpose. So there are hand operated tools, there are hydraulic rescue devices, there are pneumatic rescue devices which are used, there are stainless steel cutting equipments. Now the accident can be of a passenger train, the accident can be of a goods train also. But if the train, if it is a goods train accident, you will not need the rescue devices, but you will definitely be needing the restoration devices. So what exactly are they? This we'll see. So the first thing which we use is a 140-ton crane. Now this is a snapshot of what a 140-ton crane looks like. So this 140-ton crane is basically divided into two halves. So this is called the superstructure. The top portion is the superstructure and the bottom portion is the undercarriage. So this is the superstructure and this is the undercarriage. Okay. The superstructure and the undercarriage are connected with the help of a slew gear. So there is a small gear which is provided here, which is permitting the superstructure to rotate by 360 degrees over this undercarriage. Now this is called a jib. This is the basically arm on which the hooks are placed. So there is a main hook which is used to restore, and there is a small auxiliary hook of a lower capacity. These are counterweights. So it is simply the principle of physics that you use torque balancing, and these are some ropes which are used for movement of this main hook to be connected to this A-frame. Now this totality is called an A-frame. So this is an A-frame. Now what happens when this comes on an accident site? The jib is resting on something called a, you will find that there is one more wagon which is connected along with this crane on which this jib is resting. So what will happen on an accident site? You remove this wagon on which the jib is resting. This wagon is removed and then you raise the jib and you prepare the 140-ton crane to meet with the when you to start the restoration work. Now, these are the various movements which you should keep in mind. So, this is called hoisting. When we say that the crane has started hoisting, that means the main hoist or the main hook has started lifting or lowering the weight. This is called the hoisting motion. The jib is in stationary condition. So, we have fixed one location of the jib and the load is being lifted up or the load is being lifted down is called hoisting. This is derricking. Now, derricking is the process in which we are changing the location of the jib. So the jib can have n number of locations, and the jib can move up or jib can move down depending upon the distance at which you want to tackle the derailed wagon or the coach. So when you are changing the position of the jib, it is called derricking in or derricking out. Now, please remember again, it is a simple phenomena of torque, that if the jib is directed out a lot, so that means you have increased the distance from the center line to the point at which you are lifting the load, the lifting capability of the crane reduces. As reduces. Now, this is called slewing. Slewing is that when you fix the location of the jib, and say assuming you have lifted a load with the help of the main hook, then you're trying to slew, or you are trying to turn the jib, assuming you are trying to tackle a loaded wagon which is at 60 degrees, which is lying at 60 degrees, and when the jib is trying to pick it up and it is moving, it is trying to bring it into the central line of the track, this is called slewing operation. Now, this crane also has capability of self-travel. When the crane is attached with the formation, it can move at the speed of 100 kmph, which is the speed potential of this crane. The self-propulsion capability of the crane is 12 kmph. That means when it is light on rail, it has not lifted a load, the crane can travel by itself at a speed of 12 kmph. With load, it can travel up to 6 kmph. Now, the traveling of self-propulsion with load or without load is the condition where the crane is traveling, where the crane is not has not been propped, or the crane has not been fixed on the ground, and the crane is traveling. Now, this scenario is used when we are trying to launch girders. You see what happens? The 140-ton crane is also used for launching girders. And launching girder means that if you are trying to put a span of a bridge, and you are trying to do spanning, so you will pick up the girders with the help of this 140-ton crane and start placing it to bridge the river. And then in that scenario, the crane is traveling light. In all other conditions, the crane, when it reaches the accident site, is propped. And what is propping, we'll see later on. Now, these are some conditions which are laid. The ART has to be turned out within 30 minutes of the information received. So if an accident has happened at 1300 hours at Anand and the information comes to the control at 1305, so then we have a signal code or an alarm hooter code wherever the location the ART is placed. The closest ART, say in this case, is in Baroda Yard. So the controller has received the information at 1305 that a train has met with an accident at Anand. So they'll sound the hooter, they will start giving information, and the condition is this crane has to move from Baroda within 30 minutes of the accident. So by 13:35, the ART during the daytime has to get pushed out. If it is in the night time, it will get pushed out and within 45 minutes. Please remember, the ART never stops for anybody. And if you are nominated to the ART, or your boss tells you that you have to board the ART, you have to do it within that 30 minutes or 45 minutes. And the ART will leave Baroda within 30 minutes of the information received. Now, if it was a passenger train accident, we also will move something called a medical van. And the targets for a medical van is that within 15 minutes, it has to leave, because there is something called a golden hour concept. The golden hour concept is that if a person is met with an accident, you should try to give him medical attention within the first 1 hour, because then is the chance when you can provide immediate assistance, or there is a possibility that we may lose him. So that is why the medical relief vans have a stricter target that they have to be dispatched within 15 minutes if there is a single exit. And so this medical van, as soon as the hooter is sounded, the medical van or the ART will get dispatched. And this is one of the aspects when you do the accident inquiry. You also try to establish whether the ART has moved within the stipulated time or not. Now, the ART has to be given highest priority when it is moving towards the accident spot. Now, besides the ART, there is some small re-railing equipment also, and which is in colloquial terms called as MFD or LUCAS. Now, these are two companies which had provided these jacks to Indian Railways, but the name got stuck. So you may find that when an accident has happened and you are standing in the control, so he will say that either the ART is ordered or the MFD is ordered. We try to tackle majority of the accidents with the help of MFD because they are easier to carry and faster to set up. But sometimes if the accident is major and you cannot tackle with MFD, then you have to order the ART and ART will reach to the site. Now, these are some precautions while lifting with cranes. This we'll see when we come to the crane diagram. I think that would be, I have a photograph or not. Okay, I don't have a photograph, so we'll go back. What precaution is basically here, what they are trying to say is that when you are lifting an equipment with the help of this crane, so there is a crane driver who is sitting in the cab and he is lifting the equipment. He is lifting the equipment based on the signal which he is receiving from the crane supervisor. So first precaution he should take while lifting is that he should not give a jerk. Because if he gives a jerk, what happens? The loaded jerk again would increase the instantaneous load which is coming on the jib, and it will make the crane itself unsafe. So if you give a jerk, you don't lift it slowly, you may find that the crane itself has toppled, which has come for restoration. Or assuming when you are lifting and the lifted vehicle is not clear of its entanglement, it has got entangled in the earth or it has got entangled in another coach, then when he is lifting, a jerk may come at that point of time again and he'll make the crane itself unsafe. Or the rope which you have used for lifting has got kinks in it, so it is knotted. So if it has got kinks and you try to lift it, the rope tries to uncoil. Again, it will give a jerk. So these are some precautions. These are common sense precautions also, which the crane driver should take while he's lifting the equipment. So what happens when a 140-ton crane reaches on site? The 140-ton crane is made free on rails. The load is not going through the wheels. The load is going through something called props. So if in the crane, there are something called outriggers. So there are three outriggers here, or these are arms. Okay. So on both sides, there are arms. And if a crane comes onto the accident site, these arms are extended. So you will extend these arms like this. Okay. So these arms are extended and the crane is made free on rails. The load, when it is getting lifted from the hoist here, the load would be coming on these arms. So these arms would be taking the load, and this load would be going down to the earth through these arms. And this activity is called propping. So you prop the crane, you make the crane free on rails, and the load starts getting transmitted through these props. Now, this making of this prop is also a very difficult task, assuming that the accident has happened on a culvert. The accident has happened on black soil. The accident has happened where it is raining heavily. So you need to make a base for this prop, and that activity is called propping of the crane, or making the base of this prop. So you will dig inside the earth, you will put in ballast inside it, and you carry something called wooden packings. So you will place wooden packings on top of this surface, and then the prop will come and sit on this wooden packing. So you're basically trying to propping up the crane. And when a 140-ton crane comes on an accident site, the maximum time is taken in this propping. Because if the crane is not propped properly, a situation may happen where, let us see if I have a photograph. Unfortunately, I don't have a photograph here. A situation may happen that when you are trying to lift the load with the help of the crane, the prop starts sinking. Now, if the prop starts sinking, the crane surface does not become level, and again the crane will start toppling in one direction. So there have been instances where a 140-ton crane has capsized, the 140-ton cranes have derailed also. And because this is a time-taking activity, we take a 140-ton crane only when it is essentially required, because the 140-ton crane itself will take 1 or 2 hours to get ready, and we try to tackle these loads with the help of MFD, or the re-railing jacks, which are available in the accident relief crane. So when, if a 140-ton crane has come onto the site and you have propped the crane completely, while lifting, what will happen? There would be some designated crane staff who would be told that you have to see whether the crane is level all the time, the prop is not sinking, and there is something called a rail clip, which is also attached with the track. It's only for providing additional safety to the crane. Now, if a crane has started lifting and there is a torquing movement on the jib side, the last wheel of the crane would have a tendency to lift. Now, in any scenario, you don't want that the wheel should lift, because if the wheel has started lifting and the crane has started lifting from the rear, and you are lifting a load from the front, the crane may topple. So you have to keep the crane also safe, and you have to do restoration. Now the ARTs are classified into class A, class B, and class C ART, depending upon the composition of the wagons or the coaches which are provided in that train. So this is an A class ART, where you have a 140-ton crane, you have a max truck, and you have vehicles for the staff. There is a kitchen van, and there is a wagon which is carrying rails and crossing. So there is an engineering department equipment there. There is a SNT department equipment there. There is electrical department equipment there. So this is a full composition of a 140-ton crane with 9 vehicles, and this is called an A class ART. You have a B class ART where the 140-ton crane is not there. From the 4th vehicle to 9th vehicle, the train formation would be there. So that is called a B class ART. And there is a C class ART where you have very basic re-railing equipment. Parallel to this, there is something called an accident relief van also. In the accident relief van, it's a 2-coach formation, and now it has become a 3-coach formation also. One difference what has happened over the years is that we have made them into self-propelled vehicles now. For the ART to move, you need a locomotive, and if you remember the link which I was trying to explain, and there was a question which was asked as to why at Kolhapur we are having a flyover. So that flyover of the link is provided, that if there is an accident, if it happens, and that loco will come on top of the ART formation and the ART will move. But this was the scenario earlier. The accident relief train still needs a locomotive to move, but the medical relief equipment, we have made them into self-propelled vehicles. So there is a small diesel engine which is provided underslung to the coach body itself, and if an accident happens, these self-propelled vehicles, these 2 or 3 coaches which are attached together as the medical relief van, would move within that stipulated time of 15 to 20 minutes. So what will be there? A doctor would also be accompanying because you need to provide medical attention to the traveling public. So there is a hospital there. There would be an OT there. There would be medical equipment which would be provided in one coach. In the second coach, there would be rescue devices. So we have large amount of cutters, and those cutters or those pliers would be taken to cut open the coach bodies and start taking out people. So this is a two or a three coach composition which moves on self-propelled technology, and as soon as an accident is announced, the medical van would go towards the site. Now this is just a codification as to how the information is provided. So assuming Baroda control is located at Pratap Nagar and the 140-ton crane is in Baroda yard, and the staff which is nominated on the 140-ton crane is distributed. They may be in the electric loco shed or they may be staying at home. So we have the hooter system. There would be a hooter which would be provided at all these locations, and there are some codes which are defined. So assuming an accident has happened in outstation where the main line is blocked and the medical relief van and the ART both have to be moved. So the hooter code is 4 long and 1 short. So you will hear that the sirens have started blaring. So they will give 4 long blares and they'll give 1 short blare. And as soon as the people hear this sound, they know that an accident has happened and they start running towards the ART or the ARME, because the ART will not stop and it has to move within 30 minutes or 45 minutes. We handpick the staff which is nominated for breakdown duties. So we generally put good people, and you will find that they run and they come on these ARTs and the MFTs. Now, when the staff reaches the accident site, there is one more thing which you should keep in mind. Rule 14 by 2 becomes applicable. That means if they come to the site and you find that they are obstructing the work of restoration or they are not assisting, then the staff can be terminated under Rule 14 by 2. And personal, I think, would be covering as to what Rule 14 by 2 is. In the railways and normal courts, if you have to terminate a person, you issue a charge sheet, you give him chances to come and present his case and all. And it's a long drawn process. You need 3 to 4 months to terminate a person. But on an accident site, it is 14 by 2. If the accident site in charge says that this man is obstructing, then the person can be terminated very quickly. You come back, you do an inquiry under 14 by 2, and you dispense with the long process of an SF5 or an SF11. Under 14 by 2, you can terminate him quickly. Now, this is called the MFD or the hydraulic derailing equipment. This is a very, very simple equipment which is available in the accident relief trains. So there is a control jack which is provided. There is a control stand which is provided, and this is the control stand, and this control stand you will find have got 4 levers in it. So there is a DG set and there is some hydraulic oil which goes inside these pipes, and with the help of this control stand, these pipes get connected to these jacks, and these levers are used for raising the jacks up or raising the jacks down. These are telescopic jacks, and these jacks are placed under the wagon which you are trying to lift. Now, this is called a bridge. This is the bridge on which these jacks move, and you put these jacks on. You see, this is a moving trolley, and you will locate a jack on this moving trolley, and this is a displacement jack. So, let us take this MFD is being used to derail a wagon here. So what is being done? You will find that the jack has got we have placed a jack, and the jack is moving on the bridge with the help of the displacing jack. So this is a jack which has been used to lift. Okay, so this is one jack which has got lifted here. You will find that there is another jack which we have placed there. This is the bridge, and this is the displacing jack. So this control stand, what will it will do once you have placed it? The in this case, the wheel has, you are trying to move it in this direction. So what we have done is we have simply lifted the wagon like this with the help of this jack. We have provided another support here, and once it is lifted with the help of this displacement jack, we'll simply put the wheel back on the rail head. So this is MFD in use, and because it is very very easy to use, very fast, and that is why we use MFD at maximum locations where it is possible. This we have already discussed. You can see what is the equipment which is available in these vans later on. This is the concept of golden hour, that you're supposed to provide relief and succor as quickly as possible. Now the auxiliary van which is connected, I'll quickly show you what are some photographs of the equipment which is available in a medical van when it is going for restoration work. So you see these are hydraulic cutters. So these are cutters which are used for cutting open. It is nothing but a scissor. So you will create a small hole with the help of a drill, and then you will use these spreaders or cutters, and you will start cutting. So you see here we have started cutting the wagon body or the coach body. So we are trying to cut the coach body. Here we try to make an opening, so that once you make this opening, you can take the passengers inside, who are inside, outside. Now, what thing which needs to be kept in mind is, on an accident site, assuming you have used a cutter to cut this open, you will find that we leave a large number of jagged edges because this is a non-uniform cutting. So the instructions are that before you start rescuing people, you need to cover up these jagged edges. So the situation will not arise that you are killing a person while you are trying to rescue him. You're not hurting him more when you're trying to rescue him. So these are spreaders. So these are rescue ramps. Basically, if the two compartment walls have come closer, then you will use this to spread out. These are all various types of equipment, portable drill machines. These are angle grinders, saber saws. Okay. So this is something new which has come up. These are called inflatable airbags. What happens in some locations, you are not able to accommodate a jack. So you will use an inflatable airbag. In the bottom photograph, you see we have placed an inflatable airbag, and we lift the coach or the wagon with the help of these inflatable bags. Now, these vans also carry some lighting equipment, because assuming the accident has happened in the night. Earlier, the catch used to be that the electrical people used to set up the lighting equipment, but it used to take time. So railways have started purchasing. These are called ASCA lights. The name ASCA has come because it is from the company called ASCA, and these are with inflatable tubes. So as soon as you uh, come to an accident site, you will find that we have located 4 or 5 ASCA lights, and it is supposed to give, these are tower lights. When you kick in the generator, it starts giving tower lights. Then, with the changing scenarios of accidents, we have started providing breathing apparatus, water mesh firefighting systems, fire suits, life detector equipment. Also, one thing which should be kept in mind is, assuming if an accident has happened, which is involved with a tank wagon or a fuel wagon, petroleum wagon, then a person or a representative from the oil manufacturing company is also supposed to be called, because you don't know what are the types of gases you are dealing with. So basically, you take a clearance from him that whether I can use this equipment in this atmosphere, whether the gases have dispersed in the atmosphere and the wagon now is safe to tackle. These are some air breathing apparatus which is available, water mist fire equipment, live detectors, telescopic ladders. Now, in the zone, from the maintenance point of view, these accident relief trains or the MFD equipment is supposed to be operated on a daily basis. The engine of the medical vans is supposed to be cranked, because you have to be ready 24 by 7 to meet any accident. So there are laid down schedules that every every 2 weeks or every month an assistant scale committee would be visiting as to whether the 140-ton crane or the accident equipment is in readiness or not. Say after 3 months, a J grade committee would be visiting. So there are laid down frequencies where you're supposed to go and examine and see. Now these accident relief trains has equipment of every department. So with the SNT, they will have a large number of walkie-talkie sets. The electrical people would have a large amount of train lighting equipment, or assuming the accident has happened on the electrified territory. So before the 140-ton crane starts, you have to slew the catenary. So they will have all those equipments. The engineering people would have rails. They will have panderal clips. They will have tools. So it's a self-sufficient train. The accident relief train is a self-sufficient train, and it would have quarters for the staff. It would have a kitchen attached to the train, because when the accident work starts, you don't know how much time it is going to take. A scenario may happen that the 140 or the ART has moved from one accident to another accident. So this is a self-sufficient train. And once this train reaches there, then the work starts. Now, the key concept what I have tried to tell you is I basically tried to sensitize you as to what a 140 or an MFT is. What thing is to be kept in mind is that you have to keep this equipment always in readiness. And one method to check this is that you announce mock drills. So we keep on doing mock drills in the divisions. We keep on doing mock drills in the zone. The safety department organizes it, and you keep on training your staff. So you will find that the breakdown staff is trained literally on a daily basis as per the schedules which are defined, where we would do small mock trials by the 140, by the crane, by the ART staff in their own place. But the division may decide, the DRM may decide that we have to do a mock trial to see the preparedness of the whole division as to what happens when an accident happens. So then they have a laid down frequency that once in 3 months we will do a mock trial, and they will say that they will create a dummy mock trial saying that at 2200 hours a goods train has derailed at this one location, and we have to send the ART. So we do this mock trial to see whether the division is fully prepared, the response time is perfect or not. So the basic concept in disaster management is that you have to be always in state of readiness. This is the Disaster Management Act of 2005, in which it has been defined that what is the demarcation between an accident or a derailment or a disaster. If you declare the accident as a disaster, then you can start calling for state resources. You can call NDRF people, you can call all associate state facilities which are available to come and assist you in that disaster. So we end here, we end this presentation here. If you have any questions, I'll try to address them in the chat box, and then we'll move for the next. So we have a large number of questions. ART is an accident relief train. ART is an accident relief train. How is the destabilizing forces in horizontal direction? You see what happens. I told you that the axle, the wheel set is a free body. Why it is a free body? Because you need to give it space for it to execute turns, execute curves. So the axle is literally floating, and the wheel set has always a sinusoidal motion on the track. So if it is having a sinusoidal motion on the track, the wheel is always coming, forcing against itself to the track surface, and again going back, again coming, again going back, and giving an impact onto the rail head. So these are basically destabilizing forces, and instantaneously you may find a situation happens where this instantaneous force, its destabilizing force has become much higher than the stabilizing force. Then the wheel would either jump out of the wheel of the rail like a sudden derailment, or it will start mounting the railhead. And that happens especially in the case of positive angularity. You see what happens, assuming you are doing a right hand curve. Now in the right hand curve, the flange would have such a location where the frontal portion of the flange starts biting onto the rail, and it will have a tendency to mount the rail. So that is called positive angularity of attack, and it assists the derailment process. How does the railway coordinate with NDRF in case of disasters arising from natural causes? You see what happens in the disaster management plan, and when you go onto the control room, it is defined. We keep on, like in Nair also, we have an association with NDRF. We run safety courses where we take people for training to NDRF. Otherwise, at the zonal level and the divisional level, they associate with NDRF, they associate with civil defense. Our people are members of civil defense organization. Our people are members of TA also, territorial army also. We maintain a list of all the hospitals which are available close by to every station. The station master would have those lists. So we keep on having a continuous contact, and it is mandated that if we call NDRF, it is pre-mandated. You can say we have an agreement kind of a thing. Then the NDRF rushes to the site. Function of the auxiliary hook is that, assuming if you have to pick up a smaller component, the main hook is doing a lifting process, which is a 140-ton hook, and you have lifted the wagon, but there is an axle which is available. So rather than lowering, an axle is weighing around 3 to 4 tons, rather than, or a wheel set is weighing around 10 tons. Rather than using the main hook, you would use the auxiliary hook, which has the capability to lift 25 tons. You'll basically use that auxiliary hook, uh, and you will not use the main hook. But this brings to another question. You see what happens. The crane also has the main power pack, and it has a smaller auxiliary power. So in a scenario, what happens if I'm doing the lifting process and the main power pack fails, then I have an auxiliary power pack which cuts in, which will help me to lower the load which is lifted slowly to the ground, and then it'll help me to pack the crane. That means that auxiliary power pack will help me to lower the boom or the jib and pack the crane, and I'll take the crane back and I'll bring in another crane and I'll say that this crane has failed because the power pack has failed. What is a match truck? Match truck is that basically it is the, I told you that there is another wagon which is there on which the boom or the jib is resting. You see, the jib is very long. It is not a telescopic jib. The new cranes which we are trying to purchase are with the telescopic jibs. This jib is not a telescopic jib, so you need an associate wagon or a match truck on which the jib rests. When the train, when the accident relief train is moving and the jib is not in raised position, you need a match truck for the jib to be resting on. Why is jacking of props done in crane although it has sufficient counterweights? You see what happens when a 140-ton crane comes, and the 140-ton cranes, or you see, are on a gauge of 1676 wheel. So you are basically trying to increase the area which is taking the load. Okay, from say 1676, if I prop up, I have increased the base, which is providing me stabilization of that crane. So 1676, which was there on the on the wheels or the rails itself, has now become 4 meters. Okay, so once I increase the span, which is giving me stabilizing force, it makes the crane more stable. The counterweights are used in this scenario that if I have to increase, I have to balance the torque. I don't have space, so that the outrigger or the rigger which I am using for propping is also having 3 positions. So in the maximum position, it is the most stable. But assuming the crane surface, the place at which the accident has happened, I don't have sufficient place for the outriggers to reach in full extended condition. So I'll take it in one condition or the second condition itself. But I have to pick up an 80-ton loaded wagon. Then I start using counterbalances or counterweights. Basically, if you remember the torque diagram, the clockwise and the counterclockwise, I try to balance by adding additional counterweights on the tail of the crane, so that I am able to lift even with limited outrigger propping. I am able to lift loads. The derailment may happen also due to cracks or faults in the tracks. yes, a derailment may happen into the cracks or faults in the track. You will find that we face scenarios where rail fracture happens. Now, if a rail fracture happens, rail fracture may happen because of temperature variations. A rail fracture may happen if a flat wheel or a skidded wheel has gone on top of the rail head and it gives an impact and it breaks the rail into pieces. Now, till the time we are able to attend the rail fracture, a rail piece has fallen down, and the length is the piece which has fallen down. The length is sufficient enough that the wheel, rather than jumping, comes on a surface where there is no rail head available. In that scenario, yes, the wheel would have a tendency to jump away. Or assuming the two tracks have placed where they are supposed to maintain a gauge of 1676 and they are located with the help of pandural clips. The impact loading, the pandural clips are not fully tightened. The staff has not seen it. And because of a train which has passed, the impact of the longitudinal force which comes in such a high pattern that these pandural clips have given up and the left rail has left the location or the right rail has moved away. So 1676 has become 1800. As soon as it becomes 1800, the wheels which are fixed at 1676 location with the help of axle will drop inside. Now this is called spread gauge. In the accident inquiries, you will find that the majority of the accidents they happen because of the mistakes of minimum two people or two departments. It is never generally attributed to a single department. It is always a combination of factors which will lead to such a case. And this is more in gradual derailments, not in sudden derailments, because in sudden derailments, it is very easy for you to identify a cause. But in gradual derailments, you will find it is a combination of factors. The longitudinal forces, I have not provided proper liners on the coach axle box. If the liners have not been provided properly, I have increased the longitudinal clearance, and if I increase the longitudinal clearance, it starts giving me more longitudinal force. Now, this more longitudinal force coupled with a pandural clip which is not tightened properly will lead to a case where the gauge spreads. So, it is a combination of factors which generally leads to derailments or accidents. Okay, so we will stop here and we will move to the next uh, presentation. I have tried to answer your queries here. And the next interesting topic we are going to cover is called a coach. So we'll see what a coach is. There are basically two families of coaches which are working on the Indian Railways. One is called the ICF family, and second is called the LHB family. So broadly, there are two families. One is the ICF family and second is the LHB family. Indian Railways owns around 70,000 coaches and there are more than 100 designs. But they are predominantly on these two families or two platforms. So you can interpret ICF as one platform and LHB is another platform. When I say platform, it's a platform of design. And then you start giving variants. So if you travel in an ICF coach, you would have an AC2 coach, an AC3 coach, and a sleeper coach or a general coach. Similarly, you travel in LSP, you have an ICF, you have a AC2, AC3, AC1. So these are two platforms on which you give variants. We have around 70,000 coaches as of now, in which 50,000 procs are ICF coaches and 20,000 are LHB coaches. We are trying to replace all the ICF coaches with the LHB because LHB is considered to be much more safer as compared to ICF, more comfortable. LHB has come in with a lot of promises, and especially in cases of accidents and derailments, the loss of life or the casualty which happens in LHB is much lower to the ICF design. So around 2 years back, the Indian Railways took a decision that we'll now manufacture only LHB coaches and we'll start replacing the ICF coaches with the LHB coaches. So now when you travel, you will find that all the important trains have already switched over to LHB. And as and when we are getting LHB inducted from the production units, we are removing ICFs and putting in LHB coaches. In this 70,000, we also have something called electrical multiple units, mainline electrical multiple units, diesel electric multiple units. So these are small numbers. What exactly they are, we'll see. Before this, there are some definitions. So these coaches are divided into PCVs and OCVs. So PCV is a passenger coaching vehicle, a vehicle in which you are using for traveling of passengers. And other coaching vehicles are like your saloons, your inspection cars, your tourist cars. They are defined as other coaching vehicles. Why this demarcation becomes important is because there is something called codal life or the life of the coach. A passenger car coaching vehicle, if it is an ICF passenger coaching vehicle, we have fixed the codal life as 25 years. If it is an LHB coaching vehicle, we have fixed the life as 35 years. If it is an other coaching vehicle, if it is a saloon, we have fixed the life of the coach as 40 years because we believe that the other coaching vehicles are not so heavily utilized vis-a-vis a passenger coaching vehicle. You have much more utilization in a passenger coaching vehicle as compared to the OCV. And there are two designs. One is the integral coach factory design at Chennai, and second is the LHP or the Link Hoffman Bush, which ultimately became Alstom. So this was the technology which we took in 1990s, and the ICF technology we took in 1950s from a company which was located in Schillerin, and we started manufacturing it at Integrated Coach Factory, and that is how the acronym ICF got stuck up with this design. In 1990s, we thought that we should upgrade our technology, and when we went to LHP and we imported the LHP design. In both the cases, we did a design and technology transfer. And again, as I told you, when you do a TOT and a design transfer, you own the technology and you can start tweaking the design. And that is how we were able to give a large number of variants. So the ICF coach is an integral all metal coach design. What is meant by this, we will see. The original design capability was 96 kmph, which we upgraded to 140 kmph. And you would find that earlier all the Rajdanis and Shatabdis were running with ICF, though they are now getting replaced with LHP. LHP has a 160 kmph potential, which can be upgraded up to 200 kmph. So you have a locomotive with that 160 kmph potential. You have a coach which is there at 160 kmph potential. So the existing LHP loco combination can always go up to 160 kmph. Now these are some photographs. This is what the ICF coach looks like. This is the conventional coach which Indian Railways had been using for the last 50 years. This is the LHB coach which you would be traveling in now. This is a diesel electric multiple unit, and this is a set of coaches in which a diesel engine is provided. A diesel engine is provided here itself, and you would find that the diesel electric multiple unit, a diesel engine would be provided here, and there would be bogies on which traction motors are provided. So it is something similar to a locomotive. Only thing is, a locomotive may be a 6,000 horsepower locomotive or a 4,000 horsepower locomotive. Here, this 4,000 horsepower gets distributed across the train formation. So if you have a diesel electric multiple unit, you have an electrical multiple unit, you have an MEMU, you will find that it will have a set of 4 or 5 coaches. So there would be a small diesel engine which is provided here, and this diesel engine would be powering a set of 4 coaches. You attach another set of 4 coaches, again it has one more diesel engine, again 4 coaches behind it. So the diesel electric multiple unit or the EMU would have 4, 8, 12, 16. If you travel in Bombay suburban, you will find that it will say 9 coach train or a 12 coach train or a 15 coach train or a 18 coach train. Why? Because it has sets of multiples of 3 each or 4 each. That is why it is on a predefined number. This is an example of a diesel electric multiple unit. This is a MEMU or a mainline electrical multiple unit, something similar to DEMU. Only thing is working on traction. The DEMU was working on diesel. This is one of the variants which was launched in the AC version. This is a double-decker coach. This has been running at number of places. Now this is a rail bus. At some places you will find that we also run rail bus. Say for example, between Kalka Shimla, rail buses used to work. It's a small rail bus because the load is not there so much, but you have to provide some facility. So you maintain some rail buses. This is a solar powered EMU which has been developed for Western Railway, where you find we have provided solar panels on top of the locals to take care of the lighting load which is inside the coach. There is an interior of Tejas. There was a name of a train called Tejas. This is the interior which was defined, which was designed for the Bombay Goa sector. Now understand, inside a coach, you can provide anything what you want. This basically, once a shell has been created, you can keep on changing the design. Once inside the shell, you can have a sleeper version, you can have a sitting version, you can bring in CCTV cameras, you can bring in LED lights, you can bring in these screens. These are basically cosmetic changes, but the basic design of the coach remains the same. This was a new design which was train 18. Unfortunately, we could make only two, and ICF has now initiated a tender, a buy contract of another 44 numbers of train sets for Indian Railways. Now, this is a new inspection carriage. Earlier, what used to happen was the inspection carriages were connected to train formations, but this is a new inspection carriage which was designed in December 2018. This is a self-propelled vehicle, and it is used generally by divisional officers for carrying out inspections within the division. Now there is something called schedule of dimensions. You see what happens, the rolling stock is designed within an envelope. You have a track which is going under a bridge. There is a tunnel. There are homes and houses which can be built next to a track. So you provide a clear envelope, and that is called schedule of dimensions. Just remember, a schedule of dimension is nothing but an envelope. And when you design your rolling stock, you adhere to the schedule of dimension, saying that you cannot have a vehicle which is beyond the schedule of dimension, because then it will go and hit these structures. So you design your equipment within the schedule of dimension. Also remember, when a vehicle is moving, there is something called a kinematic profile and a static profile. Static profile is when it is in standstill condition, it gives you some envelope. And when it is traveling, it is having all those movements in the longitudinal, in the lateral direction. So there is a different kinematic profile. So when you are creating any design, a new design, you keep in mind that the kinematic profile of the equipment should always fall within the specified schedule of dimensions. Now, the coaches are also defined with some codes. Like in the locomotives, you have WDG4, you have WDP4, you have WDG3A, or a WAM4. Similarly, the coaches are also in codes. Now, you will find that when you are talking, or in railway parlance, you don't say AC2 or you don't say AC3. You would say WGACCN. Now, what does a example of a WGACCN indicate? So let us see in this example I have sent. What is a WGACCN? Now, W indicates it is vestibule. Vestibule is the connection between two coaches. On that platform or the fatta on which you jump and go to the next coach is called a vestibule. G indicates it is self-generating. There are two designs of coaches. The ICF coaches are all self-generating coaches. So there is a battery and an alternator which is provided underneath the coach. And when the coach moves, it generates electricity to take care of the light, the fan, and the AC load inside the coach. So that is called a self-generating coach. The LHP design does not permit self-generation. There is no battery or alternator underneath the coach. So they are non-self-generating coaches and you need to provide an external power source. So if you have WG, it indicates it's a vestibule self-generating coach. AC it is air conditioned, and CN is a code which is identified for 3-tier, or CW, which is a code which is identified for 2-tier. So when you see a coach body, you will find it would be written WGACCN 13 something something something, the coach number. And whenever a train is entering a platform, you'll find an RPF fellow would be writing the numbers. So basically, what he's seeing is he's seeing the train consist. He does not write AC2, AC1, AC3. He writes WGACCN 1303 entered, WGACCW 1304 entered. So this is how the codification in the coaching stock is done. And something similar to the loco link, there is a thing called which is rake link. I told you to run a train, we need a loco link, we need a rake link, we need a crew link, we need a guards link, there would be a TT's link. So this is a rake link. Rake means a set of coaches. So 15 coaches together or 20 coaches together in one train formation is called a rake. And what does this rake indicate? What does this rake link indicate? And this is, see, this is in this booklet, you would have these rake links. So here it is written that this is link number 15, 12728, 12727, Hyderabad, Visakhapatnam, Hyderabad, Godavari Express. So this is one thing which it is telling you that this link which we are going to discuss is for this train. Now this train runs every day from Hyderabad to Visakhapatnam, 7 days daily. Running time is 12 hours 35 minutes, average speed 56 kmph, number of halts on SCRS 17. Correspondingly, in EC or in the adjoining railway, you will find that this train is running from South Central to say East Coast. So this rake link is indicating how it is behaving at in the South Central Railway. It has indicated the details of what are the various halts over South Central Railway. It is telling you what is the composition of the train formation. So it has told you that this train is running with 24 coaches. Each rake is having 24 coaches. This is how these coaches are connected, and this is called the train consist or train information. This also gets reflected on the platform. Assuming you are waiting for a train to come in, you will know that AC2 is the 5th coach or the 6th coach or the 7th coach. This information comes from this marshalling order. And you come down to this link. This is the basic link. It tells that on day 1 at 17:15 from Hyderabad, the train is going at 17:15 and reaching Visakhapatnam at 5:50 on Tuesday morning. On say, assuming it has started on Monday night, it is reaching on Tuesday morning as 12728. On Tuesday evening, it starts as 12727 and reaches on Wednesday morning to Hyderabad. So there is some attention here, which is called terminal attention and primary maintenance, which we'll see later. But what this link has told you is basically that the train starts on Monday at 17:15, reaches at 5:50 on Tuesday to Visakhapatnam, starts on Tuesday evening from Visakhapatnam at 17:25, and reaches on Wednesday morning to Hyderabad at 6:15. So this is a link, and this is the movement of one rake. So to operate this link, we would need minimum 2 rakes, because there is this train 12728 has to start on Tuesday evening also from Hyderabad. Okay, so even though there is one train which is Godavari Express, but it can be sustained only with the help of 2 rakes, because one rake which has started on Monday is available again to me for running only on Wednesday. On Tuesday, again, I have to start Godavari from Hyderabad. So I need two rakes. And there is a coaching depot at Hyderabad. The coaching depot Hyderabad is having say 700 coaches with it. He will say that I have identified 50 coaches to run Godavari Express, because in this I have to give 24 coaches on Monday as a one rake. I have to give 24 coaches on Tuesday as one rake. So I need 48 coaches to sustain Godavari. Even though there is one train, it will have two rakes to sustain this link. Now, this link also tells you that in which section, what is the type of locomotive which is being used. So that is okay. And a rake link would be issued for every set of rakes like this. So, for example, you may find a rake link. In this case, this is a dedicated rake link where it goes as 12728, comes back as 12727, again goes back as 12728. Or you may find that after coming 12727, it goes and works 12765. It gets connected, the rake gets connected to some other link. Okay, so these are the things, this information which is coming out. Now, this is also telling you here that number of rakes required, 2, owning railway, South Central, primary maintenance, Hyderabad coaching depot, terminal attention, Vishakhapatnam, trip kilometers, 1422. It is actually not trip, it is link kilometers. This figure is wrongly written here. The link kilometer is 1422. So in one link, you see here, individual distance is 711. So the link is of 1422 kilometers. And this train has been given primary maintenance at Hyderabad depot. It does one round trip of 1422 kilometers, comes back to Hyderabad, and again goes in for primary maintenance. So this information uh, is getting reflected from the links. In this booklet, you will have a rake link booklet would be issued, and the rake link booklet would identify as to how all the rakes or all the coaches are distributed of that zone. So they were in the rake link book, the Hyderabad depot for his 600 coaches would be getting a rake link like this, and he needs to provide coaches as per this rake link. So the whole train formation would come out from the depot, get placed at the platform, will do this rake link, and again go back and goes back to the depot or the stabling line for scheduled maintenance. So this is information which is coming from the rake link. Now, this movement in the control office, the person who is responsible for controlling the movement of the coaches and wagons is called the TXR control or the train examiner control. These are basically supervisors or JEs who have been drawn from the field, who are doing primary maintenance and secondary maintenance, and they are placed in the control office to monitor the movements of the rakes. In case of diesel locomotives, I told you that the person who is sitting in the control is a power controller. In case of C&W, it is a TXR control. So this gentleman is sitting 24 by 7 in the divisional headquarters in the control room, and he is monitoring his rakes. So in Secunderabad division, there would be a TXR control who would be monitoring all the coaches which are coming out from the Hyderabad depot. In say Vijayawada control, there would be a person who would be taking care of all the Vijayawada coaches, Vijayawada depot coaches. And divisional level control, the coordination between the divisional level control, if there is something which happens, so then there is a control in the headquarter also who was talking to all these controls and collecting the information at the zonal level. Now, something similar to the locomotives, if the coaches are not under repair for more than 24 hours, they are called ineffective. And in this also, some percentages are defined. In locomotives, I told you ALCO is 10%, HHP is 5%. In the coaching stock, non-AC ineffective is 10%, AC ineffective is 12%. Now, this ineffective includes ineffective in the open line, that means in the depots, or also in the the coaches which are going into the workshops. Because unlike a locomotive which goes to the workshop after 8 years for any maintenance work, the coaches frequently visit the workshops. They might be going after 18 months, they might be going after 24 months, depending upon the design of the coach. And workshop is the place where larger amount of input is given to the coaching staff. The operational line or the coaching depots or the sick lines are they not having that much of time to give larger level of attention. So that is why you'll find that very less percentage of less percentage of an effectives is given in open line. Broadly, we give larger effective percentages for the workshops. This is the codal life of the coaches, which we have already discussed, that the ICF coaches have the codal life of 25 years. LHB coaches, we have codal life of 35 years. Some numbers, just to tell you that the LHB is a longer coach as compared to the ICF. An ICF coach train length is defined as 24 coaches, whereas an LHB, a 22 coach train replaces an ICF 24 coach train. Indian Railways runs 24 coaches long trains. We have India is a very unique country in the sense that we are the only country, one of the few countries in the world, which runs such long lengths of trains. Okay, so ICF is around 22 meters length, whereas an LHB is around 24 meters. It is a longer coach as compared to ICF. Now, all the passenger vehicles, all the coaching vehicles, and are identified to a depot. So, like diesel locomotives are identified to a shed, each coach is identified to a depot, and that depot is the owner of those coaches. So, if any specific schedule has to be done, if the coach has to be booked to workshop, any unusual occurrence happens to that coach, then that specific depot is answerable to that for that coach. Now, these depots would maintain block rakes. Basically, block rake is a set of 24 coaches. It's a rake, and which is maintained to a specific train. Destination boards, fire extinguishers, all this is provided by these parent coaching depots. Now, the depot would be maintaining something called a coach maintenance history card. So each coach will be having a history card, and they'll keep on recording as to what are the various schedules and attentions they have done on a specific coach. This information is shared with the workshop. Along with this coach maintenance history card, they also maintain a deficiency card or a deficiency register. You see what happens sometimes these coaches come back to us and we are booking them for workshop with a large number of items which are missing. So door knobs are missing, magazine holders are missing. So we'll indicate it into the deficiency register so that when the coach comes to the workshop, he knows what all work he is likely to do in these coaches. Now, each in the zone, some stations are identified as watering stations, where the rakes, where the train formation is watered while it is en route. And before the train gets placed on the platform, the train has come out from the washing line, then all the water tanks needs to be filled. We don't do watering on the platform from the originating station. Assuming the train has started from Baroda and it has to go to Bombay. So when it is coming from the Baroda washing line, the rake has come from Baroda washing line to the Baroda platform, it will be completely watered. It has started from Baroda, you may find that they have defined that when the train reaches Vapi and there is a stop of 15-20 minutes, we will water it again. So Vapi has been defined as a watering station for this train. We'll pump in water at Vapi and then the train goes to Bombay. So the watering stations are predefined depending upon the availability of water in that area. And you will find that generally the watering stations are clubbed with crew changing stations, because the crew also is supposed to work for 4 hours or 5 hours. Assuming Bombay Rajdhani starts from Bombay and goes up to Delhi. So the first watering station and the crew changing station is Baroda. The Bombay Rajdhani starts at 17:15 from Bombay. it has been watered, and the rake has come out from maintenance, standing at Bombay platform. It has started from Bombay. The first stop will be at Baroda, at which the crew will change. That means fresh set of drivers and fresh set of loco pilots, assistant loco pilots would be coming in, and you will find that we also water the station and water the rake at Baroda station, because we find that water has got consumed between Bombay to Baroda, and that is why one of the reasons why Baroda is also a stoppage of Rajdhani, because Baroda is one place where we can water it. Now these are some of the different examinations which are done on a train. So you have examination of an originating train when the train is starting from the platform. You have examination when it comes to the terminating station. There is something called primary and secondary. If you remember the wake link, I had written somewhere as PM and then TA. And then there are some individual schedules of the individual coaches. So there is a rake inspection, the whole formation we are doing some inspection, and we are doing some individual schedules to the coaches also. Now this is a very important document which is called brake power certificate. No train can be dispatched before this document is issued to the driver. Now, when you are foot plating also, you should ensure that the driver is having a valid BPC. What does this BPC indicate? This BPC is primarily indicating the level of brake power which is available in the train formation. When the train has been attended on the pit line or on the pit line, what is a pit line we'll see, and it comes on the platform, is supposed to have 100% brake power. It indicates that all the brake cylinders, the pneumatic brakes, which are available in the rake formation, are in working condition. And so say, assuming there are 100 brake cylinders, there are 2 brake cylinders on each coach, and there are 24 coaches, there are 48 brake cylinders. The BPC will indicate that all 48 are in 100% working order, and the brake pipe pressure on the train and in the guards when are optimum. So the BP brake pipe pressure is an indicator to tell whether there is any leakage in the train formation or not. So this information comes on the BPC, and no driver can start the train without a valid BPC. If he is starting a train with an invalid BPC, he is playing with the safety because he doesn't know what is the number of operative cylinders which are there in the train formation. So you will find none of the drivers starts a train without a valid BPC. So assuming the rake has worked from Visakhapatnam to Hyderabad, and it comes to Hyderabad, once the passengers have deboarded, you will take the train on. We'll see, you will find that we have pulled the train out and we have taken it on this washing line. So when you enter platforms, you see large number of washing lines across major platforms. Now this is a washing line. So what happens? It's a 24 coach or a 25 coach washing length line. The rake has got placed here at 7 o'clock in the morning, and it is supposed to go back at 17:15 to pick up the next Godavari in the evening. So you start doing interior cleaning, you start doing exterior cleaning on these coaches, and if there is any deficiency, you build up those deficiencies. And on the right hand corner, you see that the staff has started checking the undergear. The safety of the coach lies in the undergear. Anything above the undergear in the superstructure, it is nothing but cosmetics. The safety of the coach lies in undergear. So this gentleman at the bottom inside the pit is basically looking after the undergear equipment, whether the springs are intact, whether the brake blocks are intact, all the nut bolts are intact, the auxiliary reservoirs or the control reservoirs are intact or not. And a minimum pit occupation time of 6 hours is required to do this examination. So you will have 2 gangs. One gang will start from one side of the rake, the second gang will start from the another side of the rake. So once this rake has come onto the washing line, they will do interior cleaning, they will do exterior cleaning, they'll build up the deficiencies, they'll do the undergear examination, they will water up the train formation, they'll do adequate watering in the train, and then they'll do the brake continuity test. They will see whether the braking equipment is working fine or not. So these lines are provided with compressors and test rigs. So they will see whether all the brake cylinders are in working condition or not. And once they have provided attention on this washing line for 6 hours, which is called primary maintenance, this rake is taken out and kept on the platform for dispatch. So a locomotive will come and get attached onto the head, and it will go to the platform and it will work the train from Hyderabad to, say, Vishakhapatnam. Now the train has come to Vishakhapatnam, and the train has to start from the platform only. So that is called terminal attention or platform attention. And there is a gap of 2 or 4 hours only which is available. When the rake is kept on the platform only, interior cleaning is done and a brake continuity test is done. Again, the CNW fellows will come. They will see whether the brake cylinders are in working condition or not. So this is called terminal attention. On the BPC, they will endorse and they will say that we have checked the brake continuity and it is working perfectly fine. And then the rake will start on the reverse trip up to Hyderabad. So Hyderabad is the primary owner. Now sometimes what happens, the train is very important. Say Bombay Rajdhani. Bombay Rajdhani primary attention has been given at Hyderabad depot, at say Bombay, and the Bombay Rajdhani, after giving primary attention at Bombay, goes to Delhi. So we don't want, because Rajdhani being a more stressed train and a more important train, we say that we will take Rajdhani on the pit again and do this complete examination before it starts this reverse trip. So that is called secondary maintenance at Delhi. There is no difference between primary maintenance and secondary. The only difference is that if we say that we are doing primary maintenance at Bombay, we are saying that these coaches are owned by Bombay Coaching. They are not owned by Delhi Coaching Depot. So the Bombay depot is doing primary on Rajdhani, the Delhi depot is doing secondary on Rajdhani. There is no difference in the attention, but the coaches, because they are owned by Bombay, it is called the primary depot. A scenario may come where you have run a train where no secondary maintenance is done, only a platform maintenance or a terminal attention is given and the rake is sent back. Okay, so these are different types of examinations which are done on the rake. In both the circumstances, a endorsement on the BPC comes. The BPC is also valid if the rake integrity is not broken or changed. Okay. Every time if you change the integrity, if a loco change is involved, then the CNW fellow has to come along with the loco change and has to revalidate the BPC. He will revalidate the BPC, assuming there is a traction change. Diesel locomotive gets replaced with an electrical locomotive, then the rake integrity has broken. As soon as the traction locomotive gets connected on the rake, again a brake continuity test would be done and it will be endorsed on the BPC saying that the BPC is now valid to go ahead. Now these are some of the attentions which are given in the primary end. We see basically brake blocks, dashpot oil, intensive cleaning, brake gearing is 100% working or not. So these are the attentions at primary end. The similar are the attention at secondary end. If secondary maintenance is involved, only difference is the coaches are owned by the primary fellow. Like primary pit line 6-hour occupation, secondary pit line 6 hours occupation, terminal attention or platform return is 2 hours. This is the time which they need. Okay. So as I told you, the difference between primary and secondary is that the coach schedule history cards and the responsibility of ABC schedule lies with the primary depot. Now we run around 13,000 passenger trains across the country. And when you say 13,000 passenger trains, you may find that we are running 20,000 rakes. A train and a rake is different. So we may be running around 20,000 rakes. So we have divided these passenger trains into 10 broad categories for the purpose of attention. Like I told you that Rajdhani, even though it is earning only 1200 kilometers, we do a primary and a secondary maintenance at both the ends. Whereas, say if it is a Shatabdi, we will do primary at Bombay, we'll do terminal attention at Ahmedabad and send it back again for primary at Bombay. So, depending upon the importance of the trains, we have divided all the trains in the country in 10 broad categories. And the basic principle what we have tried to follow is this. You can see what we have done. The basic principle we have tried to follow is that one BPC, if it is an ICF train, should be valid up to 3,500 kilometers. If it is LHP, it should be valid up to 4,000 kilometers. So if you have a day train which is going from say Baroda to Anand, from Anand it goes to by another name to Surat, from Surat to say Godhra, from Godhra to say Ratlam and back to Baroda. So one rake has done 7 or 8 trains. So every time we do not take it on the pit, we say that once I have given you a BPC, if it is an ICF formation, it is valid for 3,500 kilometers. If it is an LHB formation, we will make it valid for 4,000 kilometers. So like this, we have divided our trains into 10 broad categories and which we define as to where would we give primary maintenance, why we give secondary maintenance, why we give terminal attention. So this is at the level of the train or the level of the rake. But the rake consists of coaches and there are individual schedules for these coaches. So these coaches are defined in the case of ICF in Schedule A, Schedule B and Schedule C. So Schedule A is supposed to be given every month with a grace period of 3 days. We do all the items which are covered under the normal pit line attention. The coach need not be detached from the rake formation. Some more items are covered under Schedule A. Assuming we may say that in Schedule A, we will also paint the interiors, we will replace the panels. So that is some level of attention which goes in Schedule A is higher than the primary maintenance. Similarly, we have Schedule B, where we say that every 3 months with a grace period of 7 days, we will do a Schedule B. In this, the level of attention is more than the items which are covered under A. And the most important schedule which we do is called IOH or intermediate overhaul, which we do after every 9 months. Now, what is important in this is that in this case, we basically detach the coach from the rake formation, take it inside the coaching depot, lift the coach, run out the bogies and dismantle the bogies, push in fresh bogies. We check all the spring chambers. If the wheel sets need machining, so we do wheels machining, we do axle box attention. So the level of attention in IUH is primarily safety related. We do ultrasonic testing of axles. Okay, so these are some of the items. Basic difference, A and B, we do not detach the rake. We do not detach the coach from the rake. In the consist of the rake formation on the washing line itself, only we will pay attention to these coaches. But in the case of if the coach is due for for the IOH schedule, we will detach the coach from the rake, take it inside the depot, lift it, attend to it, and then put it back inside the rake formation. Okay, so like these are the important activities. The bogie frame should be checked for damage, cracks, deformations. So IUH is a very, very critical schedule which is done at the depot's level. Now, there is something called en route or en route examination. You would have seen that people sit on both sides of the platforms. And this is what they are trying to do is this is called rolling in, rolling out examination. When the train is rolling in into the platform. So let us take the example of Bombay Rajdhani again. Bombay Rajdhani, when it comes to Baroda, you will find that before it is entering Baroda, two gentlemen, one gentleman on this side and one gentleman at the opposite side would be sitting and watching this train formation. Or when it is rolling out from from Baroda, they would be doing this. And what are they basically seeing? In the undergearing portion, they are seeing for any loose hanging part, they are hearing for any unusual sound, they are seeing whether the springs are intact or not, they are smelling whether any grease has come out. They are basically inspecting the undergear examination. And this is called rolling in, rolling out. In this, generally the speed of the train should be less than 30 km so that they are able to examine it. This is a very, very critical examination that between Bombay to Baroda, if something unusual has happened. This rolling in, rolling out is also done similarly in the wagon stock, and it is done generally at every 300, 400 kilometers. You will find that Bombay Rajdhani rolling in is done at Baroda, and then a rolling in would be done at Ratlam before it is going to stop. This is done just to ensure that the safety of the train is not compromised. And this becomes very critical. We are trying to replace all these inspections with technology. So you will find that high-speed cameras are now replacing these men, and the high-speed cameras are taking photographs which are analyzed with alarms, inbuilt alarms. If they find any defect, then they give alerts for the people to come and attend. So rolling and rolling off is very, very important. A large number of accident cases of passenger trains which have happened in the past have also attributed defects to the last rolling in, rolling out examination points, where assuming the train has failed after 200 kilometers of the last rolling in examination, and you find that an unusual sound came or a jerk came or a spring flew off, then this rolling out point would be caught. Partner, 200 kilometers earlier only you had examined the train. Why were you not able to catch this defect? So this is called a rolling in, a rolling out examination. And we will stop here and we'll start from this slide in the next presentation. In the meantime, I'll try to address your questions. Railbus uses demo technology. You see, different rail buses use different technologies. Like some are very rudimentary. We have also fitted a truck kind of a cardan shaft and an axle drive. Demo technology is generally is defined where the engine is more powerful and it can carry 3-4 coaches. We have converted these rail buses with something called a diesel hydraulic multiple unit technology, where we are using transmission, where we are using hydraulics in the transmission system. Please explain types of coach availability again. Types of coach availability means I have not understood this question, Amit. You have to either tell me what is meant by this. Types of coach availability.
Sir, in the slide where there was a percentage of availability 90%.
Okay. So I will come back. What happens? I told you that if a coach is not available for more than 24 hours, it is called ineffective. Okay. So the each depot is provided some spares. So again, we took the example of that Godavari Express, and we said that he needs 48 coaches. Okay, so he's having 600 coaches. Assuming a depot is having 600 coaches. Now you need to give him some maintenance spares. He cannot keep all 600 coaches all the time online. He has to detach coaches for intermediate overhaul from the rake. He has to replace an AC2 with an AC2. So you give him some percentages. In non-AC, I have given him 10% ineffective percentage. Assuming out of 600 coaches which he is having 300 non-AC coaches. So I will tell him that out of this 300 coaches, on any day or at any time, 270 coaches should be given in working order in the rake function. 30 coaches you can keep as ineffective. effective. Now, in this 30 coaches, again, I have said that 2.57 coaches can stay inside your depot for some unusual attentions, but the balance 23 coaches have to be sent to workshops for periodic overall, where a larger level of attention is given to these coaches as compared to what the depot can do. Now you see what happens. You find in a coach where Rexine has got cut, the seat berth has got cut. When it comes to the coach depot, that fellow would be able to do only patching. So you will find that a glass has broken and they will put a patch on top of it because the depot has to turn out the coach. He will only do patching. But when this coach comes to the workshop will remove this glass panel and put a fresh glass panel. So this is the level of attention which differs because the depot cannot engage in replacing the glass. There are 600 coaches which he has to maintain and he has very, very less time to attend. But when the coach will come to the workshop, there is a time cycle of 10 to 12 days, say, which is available to him. There he can do more intensive maintenance work. So out of these non-AC 300 coaches where I've given him 30 spare ineffectives, he can keep 7-8 with him, and for balance 20 to 23, he should send them to the depot. Ineffective is if the coach is not available for more than 24 hours. Can a train be entirely solar power propelled? Does the surface area current technology conversion efficiency allows it? The train cannot be 100% solar power paneled directly. Solar paneling, which we have tried to do now, is basically to take care of the light, fan, and the AC load. Yes, if you have a surface area like at Bina, Indian Railways has set up a solar power plant where it is generating 2.5 megawatt, 3 megawatt. That electricity gets connected to the catenary, and from the catenary you can take the power. As understand, it is say in a diesel loco, it's a 6,000 horsepower locomotive. You convert it into megawatt, you see how many panels would be required. Train is moving space. Under no circumstance can you put so many panels on top of the coach body that it can give you power for propulsion also. So directly it cannot be. Indirectly, in the sense, if you put a large number of panels and then you take the electricity through the catenary, yes, it can be done, and it is being done. CNW stands for carriage and wagon. Can ICF and LHB type coaches be used in the same rake? No. ICF and LHB cannot be used in the same rake because the braking characteristics are different between ICF and LHB. Second, ICF is a self-generating coach, whereas LHB is a non-self-generating coach. So if a rake which is having ICF and LHB both, you will find that electricity is available for only 6 coaches. Electricity is not available in the balance 6 coaches. That is one. Secondly, the braking characteristics of both the types of coaches are different. So when you do apply brakes, you will find that ICF behaves in one way, the LHB behaves in another way. So you cannot club them together. Why do we need EMU, MEMU, DMU for suburban trains? Why can't a single engine drives all coaches? Yes. This we will cover later on in the presentation, where we will see what is the benefit of distributed power. This is basically, these are train sets where we are using distributed power. Why have we distributed the power in EMU, MEMU, DMU and are not using localized power? This we'll see later on. Difference between a rake and a train. Like I told you, Godavari Express, it's a train. It is Visakhapatnam to Hyderabad is a train. But to run that train, you need more than one rake. That means more than 124 set of 24 coaches. Because Monday, if it has started from Hyderabad, it is coming back to me only on Wednesday. But Tuesday also from Hyderabad, I have to start a train. Okay. So I need 2 rakes. Rake is nothing but a set of 24 coaches or a consist of 24 coaches. It can be 20, it can be 17. This is the difference between a rake and a train. So there may be a train which is being run by a single rake. There may be a train which is being run by 3-4 rakes. For example, you have AP Express or a train, say Vivek Express, which runs from Kanyakumari to Guwahati. Now it takes 3 days. So the rake would be available to him only after 6 days of round trip. But if he has to run this Vivek Express every day, then he needs 6 rakes, because the rake is coming back to him to run the same train after 6 days. 6 days. So this is the difference between a rake and a train. Okay, so I'll end here. Thank you, because I have another class at 11:15 and you have already taken me up to 11:10. Bye bye.